Hi, oh, oh, Hi, I'm Daquan, and my synthesis project was on reductive duration of ketones with magnesium and DTO for the synthesis of A-duratol O-methyl benzyl hydro. Scale and optimization. There is a large amount of gas generated, but it doesn't really give us a scale on how big or how small this experiment should be done. This experiment takes a long time, so it should be somewhere that's always accessible, somewhere where you can spend a lot of time. An excessive amount of magnesium is required. Magnesium Turner was purchased from Alpha Acer and is used as received. The checking process. It was checked by Yuki Watanabe, Koichi Hagawara, and Masayuki Inoue. This is a fast exothermic reaction. It is advisable to conduct these experiments in a large flask fitted with large thermos. This is what the checker said, but the submitter said a line condenser. The atmosphere of the reaction system is argon, said the checkers, when the submitter actually said the atmosphere of the reaction is nitrogen. In this reaction, magnesium as a reducing agent loses electrons on the metal surface. It needs enough metal surface area to contact the ketone. There is still some magnesium left after the reaction, therefore an excessive amount of magnesium is required. Magnesium was purchased from Alpha Acer and used as received, said the checkers, but the submitters, they said the freshly peeled magnesium was peeled from magnesium rod by using planer. Magnesium was purchased from Alfa Romero, but they didn't say like how it actually happened, so the checker had to help me. Reaction apparatus. A 500 milliliter 3-neck round bottom flask is equipped with a Teflon coated magnetic stir bar, which is oval shaped 5 by 2 centimeters. The side necks are fitted with a 15 out of 25 rubber septa. The central neck is equipped with a connecting adapter and a water-cooled reflux Duramoth condenser, which is topped with a 15 out of 25 three-way cock connected to a ski link line. This is how the three is set up. Reagents and starting material. Duration of ketones is what we started at. A deterioration O-methyl benzyl hydro, magnesium, tetrahydrophon, 1,2-dibromethane, 2-methyl benzophenol. Reaction procedure. A 500 milliliter 3-neck round bottom flask is equipped with a Teflon coated magnetic stir bar. The side necks are fitted with a 15 out of 25 rubber septa. The central neck is equipped with a connecting adapter and a water-cooled reflux Duramoth condenser, which is topped with a 15 out of 25 three-way cock connected to a ski line. All junctures of the glassware and the rubber septa of the side neck of the flask are sealed with Teflon tape. The rubber septa of the side neck of the flask is removed and magnesium turning, which is 2.4 grams, is added through the side neck. The rubber septa is reattached and sealed with Teflon tape again. The resultant magnesium is dried by a heating gun under vacuum for 3 minutes, after which the flask is filled back up with argon. The process is repeated 3 times. The reflux condenser is kept at room temperature, which is 23 degrees Celsius, with a condenser flow of water. Following the addition of THF, 30 milliliters, by a syringe through the rubber septa of the side neck flask. The reaction vessel is preheated to 70 degrees Celsius silicone oil bath and stirred for 25 minutes. 1 out of 2 dibromethane, which is 3.46 milliliters, is then added to the flask via syringe over 20 seconds. Can't be slower, can't be faster. Through the rubber septa of the side neck. And the reaction is stirred for a minute. At this point, a mixture of THF, which is 10 milliliters, 2-methylbenzophenone, which is 3.6 milliliters, and D2O, which is 30 millimoles, is added via syringe over 1 minute, not too fast, not too slow, through the rubber septa of the side neck of the flask. After the reaction is stirred at 70 degrees Celsius for 2 hours in an oil bath, the reaction vessel is removed from the oil bath and cooled at room temperature over 30 minutes. The solution is then quenched with sequential addition of 100 milliliters of dichloromethane and saturated aqueous ammonium of 60 milliliters under stirring. The saturated aqueous ammonium chloride is added in 3 20 milliliter portions over 30 minutes. So every 10 minutes. 100 milliliters water is added to the flask and solution is stirred at approximately room temperature for an hour. The resultant mixture is then transferred to a 100 milliliter separatory flask. This is rinsed with dichloromethane and water. The layers are separated and the aqueous solution is extracted with dichloromethane. The combined organic layers are dried for 10 minutes over a hydrous magnesium sulfide diphorate and filtered through a cotton plug into a 100 milliliter round bottom flask. The filter cake is rinsed with dichloromethane and the filtrate is concentrated on a rotary evaporation under reduced pressure to give crude mixture as a colorless oil. 4.5 grams of cilia gel and dichloromethane 50 milliliters are added to the resulting crude oil. The mixture is concentrated by rotary evaporation to afford a white solid. The resulting solid is purified by column chromatography on cilia gel using petroether and dichloromethane as eluents. The fraction containing the products are combined and concentrated by rotary evaporation. The purified material is placed under vacuum for 5 hours to afford A-ditro-O-methyl benzohydrol as a white solid with 99.3% purity determined by QNMR analysis. The order of the reaction is very important. Reaction workup. The 3-neck round bottom flask was set up. 3.46 milliliters of 1,2-dibromethane was added to the flask over 20 seconds. Then a mixture of 2-methylbenzophenone of 3.6 milliliters and D2O of 30 milliliters is added over a minute. After this reaction is stirred at 70 degrees Celsius for 2 hours in an oil bath, the reaction vessel is removed from the oil bath and cooled at room temperature over 30 minutes. The solution is then quenched with sequential addition of 100 milliliters of dichloromethane and 60 milliliters of saturated aqueous ammonium chloride, then stirred. Then the saturated ammonium is added in 3 20 milliliter portions over 30 minutes. This is the different reactions that I just told you about. Purifications. Cilia gel and dichloromethane are added to the resulting crude oil. The mixture is concentrated by rotary evaporation to afford a white solid. The resulting solid is purified by column chromatography on cilia gel using petroether and dichloromethane as eluents. The fraction containing the products are contained and concentrated by rotary evaporation. The purified material is placed under the vacuum for 5 hours to afford A-ditro-O-methyl benzohydrol as a white solid with 99.3% purity, determined by QNMR analysis. This is the 5 different tests that was ran, and you see the purity is pretty high. Safety notes and hazard warnings. It should be noted that there is a large amount of gas generation after the 1,2-dibromethane was added to the solution. The time over which 1,2-dibromethane is 15 to 40 seconds. The 1,2-dibromethane should not be added too quickly or shouldn't be added too slowly. The time required for the addition of the mixture of the THF, 2-methylbenzophenone, and D2O is about 1 minute. The mixture shouldn't be added too quickly or too slowly either. This is a fast exothermic reactor. Discussion. Deuterium was discovered by Harold C. Urey. A variety of substituted benzophenols can be transported into the desired products in good yields with greater than 89% deuterium incorporation substrates with a moderate electron withdrawal group, such as fluorine or chlorine, afford the corresponding products. I think I could run this synthesis in our lab. This is all the different reagents and reactions and purities. Discussion. In conclusion, a practical method for the reductive deuteration of carbonyl compounds to a deuteration alcohols with excellent deuterium incorporation is reported. Only 1.5 equivalents of the DTO were required for these highly efficient transformation. The method is economical and features good substrate scope and excellent functional group tolerance. Authors. Nego Zhu received a PhD in organic chem from the University of Chinese Academy. Currently is an assistant research fellow at Fujian Institute of Research on the structure of matter. Chinese Academy of Science. Interest in developing new organic synthesis methodology and introducing organic reaction into polymer chemistry. Wen Ming received a PhD in polymer chemistry and physics at the University of Science and Technology of China in 2010. He's currently a professor at Fujian Institute of Research on the structure of matter, focuses on intro to barrier polymerization. Hangalik Bao received her Bachelor's of Science degree in chemistry from the University of Science and Technology of China in 2002. She obtained her PhD from the joint program of Shanghai Institute of Organic Chemistry and the University of Science Technology of China in 2008. She started her independent career in 2014 at Fujian Institute of Research on the structure of matter, Chinese Academy of Science. Interested in new metal catalyzed reactions and asymmetric catalysts. Yuki Watanabe was born in Kanagawa, Japan. He graduated from the University of Tokyo in 2020 with Bachelor of Science in Pharmaceutical Science. He's in graduate school at the University of Tokyo, interested in the area of total synthesis and complex natural products. Koichi Hagawara was also born in Kanagawa, Japan, but in 1989. He received a Bachelor's of Science in 2013 from the University of Tokyo and his PhD degree in Pharmaceutical Science in 2019. He was appointed as a professor in the Graduate School of Pharmaceutical Science at the University of Tokyo in 2017.